So let us start with this question of integration. So how are we going to calculate this integral? Let's see. So here we are going to use a substitution, that is put under root x minus 1 equals tan theta. Now this gives us many things. First of all, this implies x minus 1 equals tan square theta, or x equals 1 plus tan square theta, which we know is nothing but secant square theta. Secondly, take this and differentiate with respect to x. What are we going to get? So let's see this question of integration. I equals integral under root x minus 1 upon x square dx. So for this, let's use a substitution. So put under root x minus 1 equals tan theta, which implies x minus 1 equals tan square theta. So your x equals 1 plus tan square theta, which is secant square theta. So this is an identity, we have learned it in junior classes. Next, also taking this and differentiating with respect to x, we are going to get dx equals 2 tan theta secant square theta d theta. Now I have differentiated tan square theta on right hand side by using first of all that rule that d by dx of x raised to the power n equals n x raised to the power n minus 1, and after that, since instead of x we have some function that is tan theta, so after that I have used chain rule. That means afterwards I have differentiated tan x, which is secant square x, the derivative of tan x, and at last d theta. Now see this and this one and this one. So our integral becomes I equals integral, that is you're going to get, instead of this I'm going to write tan theta, instead of dx I'm going to write this value, so that's 2 tan theta, it's secant square theta d theta, and in denominator instead of x square I'm going to write this thing, the square of x, so this is nothing but secant square theta whole square. Next, now this is second power of secant theta, which is going to cancel with 2 secant thetas in the denominator, and we're going to get I equals integral, see that's 2 outside, tan square theta d theta upon secant square theta, right? So I have obtained this integral so far. Now in the numerator, this tan square theta term, I'm going to replace this by this value, secant square theta minus 1. So I'm going to get I equals 2 secant square theta minus 1 upon secant square theta d theta. So I equals 2 integral. Now when I separate out this secant square theta individually with both these terms, I'm going to get 1 minus 1 upon secant square theta, and that is nothing but cos square theta d theta, which is equal to 2 integral sine square theta d theta. And now this is equal to twice of, now I'm going to use a formula of cosine, which is cos 2 theta equals 1 minus 2 sine square theta. So from here I'm going to calculate the sine and substitute it here. So that's sine square theta equals 1 minus cos 2 theta by 2. So this value. So that's 1 minus cos 2 theta, that's 2 theta, upon 2 d theta. That's, these two are going to cancel. And now we're going to integrate this and we're going to get, remember, don't forget to mention this plus c along with, because that's the constant of integration, and this is mandatory in indefinite integration that we had just done in this question.